All right, guys, we've been lecturing about arrays. We know what an array is. It's just a series of pieces of data, data of the same type that share the same name. And then you can pick out which piece of data you want via an index number, a subscript number. Just like apartments. You have an apartment, all the apartments share the same name, Wyndham Hill Apartments, but then the separate apartment numbers access the individual apartments. Same idea. So sometimes you need to find a location in the array with some data so that you can change it or so you can access it or something like that. And in that case, you do something that's known as a linear search. Well, there's more than one kind of search, but the linear search is the one that we're going to talk about today. Linear just means in a line. The way it goes is you just start at the beginning and then you go to the end, keep looking for the item that you want. So say I'm looking for somebody who's 24 years old. I ask you, are you 24? You go, nope. I ask you, are you 24? Nope. I ask you, you say, yep. So there, we found it. What I can do then is I could be keeping track of the index number as I go along. All right, I'm at index value 0. Are you 24? Nope. I'm at index value 1. Are you 24? Nope. I'm at index value 2. Are you 24? You tell me, yep. And okay, great. I need to be able to keep track of that too, so that later on when I want to do something with that data, I can do so. Now this book shows a slightly different way of doing it. There's a couple of different things that you can take into consideration. One is, do you want to find the first person who's age 24? Or do you want to find the last person who's 24? Or do you want to somehow make a list of everybody who's 24? Do you want to just suddenly stop when you find your first 24? Because that might be the most efficient, right? What if you have 10,000 students in your college and you're searching for a specific ID number? Do you want to have to go through all 10,000 records every time you want to access that person? No. If you can keep searching, and then stop when you find the record, you're better off. So we're going to set a flag, which is a Boolean variable, a true-false variable, that says whether we have found it or not. And it's going to start at false, right? We have not found the person who's 24 yet. And then we're going to set a subscript variable to 0, so that we start at the beginning. So that flag gets set to false, the subscript gets set to 0. We start examining each record in the array with a while loop, a for loop, or whatever. If the value ever matches, set the flag to true. If the value does not match, increment the subscript and examine the next array element. Now, according to this list here, this kind of pseudocode here, they don't actually keep track of which index number contained the good data. If we look at their little flow chart here, it still doesn't address that. So, I'm going to show you a way of doing it. No, still not finding it. Going to show you a good way of doing it. So we're going to need two variables. One, a found, which we set to true or false, that's our flag. And then a found at. And found at is going to be the index number of what we find. And there's more than one way to do this, and maybe we'll code it two ways, but I don't want to stick too many things in your brain, too many competing ideas. So we set our flag to false, if I can type. Turns true when we find the element, right? Whatever our criteria is. And then we do found at equals to -1. That's the index number of the element found. And if we get all the way through the loop and found at is still equal to -1, we know we never found it. And then we're going to need an index counter. That's subscript. We're going to start at 0 and we're going to go to the end of the array. I could use a for loop, I could use a while loop. I'm going to use a while loop in this case. While the index number is less than the length of the array, if the value of the array is equal to our target value, our search value, then great, we found it. Found is equal to true, and found at is equal to our index value. Now this is still going to search all the way to the end of the array. So we might want to optimize it a little bit. Modify the while statement to take advantage of the and, because we could keep it going under two conditions. While our index is in the proper range, and while we haven't found it yet. So while the index is not equal to the length of the array, and found equals false. Like that. There's a couple of optimizations you can make to this algorithm. That's one of them. You stop early. You don't search all the way to the end. Alrighty, and then by the time we get here, we have two ways of checking to see if we found it. If found is equal to true, great, do something with it. Do something with array at index found at. Right, because index found at contains the index value where we found it at. I was going down the row. I found out that the third index, the person was equal to age 24, so I tucked that 3 away in the found at variable so I could use it later. Or you could just say if found at is greater than or equal to 0, then we found some good data. Do something with array position found at. And that's using this integer variable, the index variable, as also our flag. If you did that, you could get totally away from using the flag variable, right? Because we're also using found at for the same purpose. But I think that this is the easiest, and I've done the same thing I always forget when I write a while loop rather than a for loop. Does anybody spot what I did wrong there? I initialize my loop control variable, I have my condition, and then what's the third thing I always need to do in a loop? Well, yeah. How am I going to end it though? I have to update it each time, right? Because if the index never changes, then it'll just be an infinite loop hitting the same, element over and over and over. Salesman keeps banging on the door of the first apartment, never goes to the next one. All right, so that's what's known as a linear search. Tempted to make y'all flowchart it. Did we draw any flowcharts last week?
No.
Well, we're going to do one this week. All right. So go ahead and go to Lucidchart or your favorite flowcharting program. Log in with your student account. Google. Now, this isn't an entire program, right? What's missing from it? This is just more like a module, right? Because we didn't show how we got the data. Populate array, ask the user for the search value, right? We skipped a couple of steps. Populating the array, maybe we read it from disk, maybe we asked the database to give us, a list of all students, from this semester or whatever, read it from a file. And then we ask the user for the search value. We could just change that to input search value. And maybe we ought to actually code this in idle before we draw the flow chart. That'd probably be useful. let's do that. Let's code it first, and then we'll flowchart it. Should we do it the other way? Yeah, probably. Let's flowchart it first, and then we'll code it. I don't care if I have access to that or not. All right. I'm just going to copy this code and paste it into my flowchart so that I can reference it without toggling back and forth. Probably won't even make it visible to y'all. It's going to be really small type. But all right, so I'm going to go ahead and put a start up at the top. But I'm going to put a comment here, linear search. So I did start and then # linear search. And by the way, if you hold the Alt key down while stretching these boxes out, it behaves much better. Because if you don't do that, it kind of changes the position of it. But if you hold the Alt key down, it keeps the position and changes the size, which is useful when you have lines coming to it. Alrighty, so we need to populate the array. However, we're going to do that. We don't really have a way defined. It's kind of an input-output function, so I'm going to go ahead and put it in a data block. And populate just means get some data and put it in it. We're not saying how we're doing it. Now we have a couple declarations. Found is equal to false, and then found at is equal to -1. So a couple declarations, those go in a math block, process block. Declarations, shift enter, shift return will go to the next line, so we'll control enter, control return. All right, found is equal to false. We could capitalize false because that's what you have to do actually in Python. It doesn't matter for pseudocoding or flowcharting, but I'm going to capitalize false. And then shift enter, found at equals -1. And there was one more declaration that I could have put in there. I didn't, so I guess I'll put it in the next block. And that's index is equal to 0. All right, now we have our while loop. A while is a decision, just like an if, so what kind of shape is going to go in? Yep, the diamond. The decision block. All right, now this is actually a fairly long while statement. So it's going to be a lot of typing, and I'm going to wind up stretching the block really large to make it fit. But while index is less than len parentheses array and found equals false. And then I'm going to use the Alt key to stretch out my shape. See, if I wasn't using the Alt key, then the lines going to it would get out of whack. Yeah, I can't make this look good. that's probably about the best I'm going to be able to get it. If you have the statement while found equals false, that's the same as saying not found. Exclamation mark found. Or NOT found in Python. But I'm going to leave it like that. That's the absolute clearest. Man, that looks ugly. Not much I can do about that and keep the font size large. Well, there we go. Alrighty. So that's our while loop. We have some code that's indented in it. So I'm going to shoot off to the right, just like we were tabbing over. And this statement is if array index, subscript index, is equal to our search value. Now we never asked for our search value. I made a mistake. I'm going to have to go in and throw in an input search value up here. So I guess I'll do that right underneath populate the array. So I'm going to grab all this. Oops, I'm not going to grab that. I'm going to grab all this stuff and pull it down to make room for one more input statement. And I'm honestly not going to even take the time to correct the line. I'm just going to plop this down on top of it. So input search. I've waffled between calling it search and calling it target. Does the book give us a cool term for that? Not really. Okay, fine. Change my mind. I want to call it target. Well, that didn't work. I was trying to line everything up, so I grabbed everything and I right-clicked and I did align by center, and that didn't do a darn bit of good. I'm not going to worry about the alignment. Okay, so now I'm back down here to the decision block. While the index is less than the length of the array, then we check, have we found the correct item? If array index equals the target. So that's another decision. If array subscript index equals our target. And by hitting Shift Enter in the middle of my statement, I can make it look a little prettier perhaps. All right, now if that's true, then we have found it. We have found our block. So we need to set found equal to true, and we need to set found at equal to our index, our current subscript. So found equals true. I almost don't, kind of waffle between putting more than one statement in a block or not. But, and then found at equals the index value. I'm not liking where it put my lines, so I'm going to correct that a little bit of that. Not spend too much time on it. All right. Now, since it's an if, we have to have two branches, and they have to connect back up to each other. The while has two branches, but one of them loops back to itself. So eventually we'll loop back to ourselves. But anyways, so these guys have to connect back up. Let's make sure that there's no else. Nope, there's not an else. So we're just going to draw two lines and have them connect in a little circle. I don't need the letter A in it. I don't need it to be that large. I don't care if you take the time to make it smaller and remove the letter from it or not. Alright, I goofed. That's real dumb. I totally chose the wrong decision block to hook back up. Even if I hadn't said that, you would know this is totally wrong because this is a while loop and nothing's coming back to it. So I just have a bunch of stuff to delete there. Where did I really want it to connect? Right there. I wanted this to connect back up. With underneath the if. Whatever. Is it the prettiest? No. Alrighty, that's the end of this block of code. If we come back and look over here, we have done this. No, we haven't. I forgot the index plus equals 1. So that's the first statement after the two lines rejoin. So index plus equals 1 is math, so I'm going to drag a math block down there. You know, you could say add 1 to index, index equals index plus 1. Add 1 to index. If you like saying index plus equals 1, that's totally fine. Alright, where are we on our map? That's what it looks like so far. Now we are at the end of our while loop. If we come back over here and look, we've done all this stuff. So we're at the end of the indented code, but this is a while, so we have to loop back up. So I just need to draw a line from here back up to here. And the book always shows it going like that. You like doing it that way? That's cool. If you want to draw it so that it hooks up down to the bottom instead, that's cool. I guess I'm going to try to be like the book for once in my life and do it like that, but I'm going to have to stretch this line way out to get it to work. Now, to me, that looks ugly. I don't like that. I'm deleting it, and I'm going to do it my favorite way, which is to jut out from the other side and then kind of hook up to the bottom like that. You can still see it's a loop. Come on. Alrighty, so by the time we're done with our loop, we've either found it or we have not. We know we have found it if this flag found has ever got set to true. So it'd be nice to, just go straight down and add some code here, but I'm going to kind of, I don't know, maybe I'm going to tilt it off to kind of to the side here. The directions don't really mean all that much. So I'm going to make this come over here to another if statement. Maybe I should have made it go straight down. Whatever. All right, so there we go, and now we need to see if we found it. If found, or you could say if found is equal to true. They both mean the same thing. If found, then we're going to, I see why I should have, there's no room here, right? So I'm going to have to drag this if found all the way down here to the bottom. Just create a new page in my case. Alrighty. So if we found it, do something with it, right? Whatever do something means. Print it out, who knows? I'm going to put it in a process block because I don't really know what I'm going to do. Do something with array subscript found at. We could just output it, whatever. Whatever do something's going to be. Ask them to enter new data, who knows? But if we didn't find it, then we should probably let them know. So I'm going to put an else, a no, on the other side and I'm just going to output data not found in array. And that looks like a good thing to have told them on the other side too. So really I should have added a data block on the other side that said output data found. Data found in array. Now I have this rogue yes here for some reason. Okay. And then they're going to hook back up and we're done. So we're going to go to a circle and then we're going to stop. So we're done. All right, this wound up being, it's not a huge flowchart, but it took up a lot of space, right? Scrolling from top to bottom. If you need a printout of it, let me know. All right. Anyways, go ahead and save your document. Save as linear search, or put today's date on it, or whatever you feel like. And then do a download as, so that you can upload it. Alrighty, I wish I had two projection screens because I'd like to keep this while I'm coding. But you can do that, right? You've got enough room on your screen to keep, a picture open while you have idle in the foreground. So that's what we're going to do next. We're going to code it. There you go. Now, in the interest of time, where we say populate array, we're just going to give it a series of values, in an initializer list, like we have done in our last several examples. So I'm going to launch idle, do a file new, do a save as, and call it April 23 or whatever you're feeling. Don't save it in the Python directories, put it in your own folder. And I was an idiot and I saved the shell rather than the script there. I'm going to kill that, relaunch it. Idle. I didn't do the file new. Alright, once more with feeling. New file, save as. Yeah, maybe I can keep them both open. Alrighty, I'm going to put some comments, name, date, what are we studying? We're studying arrays, linear search of an array. So I'm going to put some comments here, and then I'm probably going to wind up replacing the comments with real code. Populate array, and then input target value, and then some declarations. Oh, I don't feel like. Okay, declarations. Okay, so found is equal to false, because we haven't found it yet. Found at is equal to -1, because we don't have a valid index number. And then index is equal to 0. Okay, now I skip the populate array and the input target value. So underneath the index, I'm just going to put a comment. While loop, and then if found is equal to true, print, we found the data at index, end quote, comma, found at. Else colon, print, data not found in array. All right, at this point it'll actually run, but it'll always say that data not found in array. Why? Because we never created the array, we never inputted a search value, and we don't have our while loop. But we'll fill in those pieces. I guess after I said that, I should actually run it to make sure that's the case. No syntax errors. Okay, data not found in array. That was to be expected. So I need to create an array. An array of colors, an array of names, whatever. Let's do colors. Array is equal to square bracket, red, end quote, comma, beginning quote, blue, end quote, comma, and then just add some more colors. There, I had about 5 or 6 colors in my list. Just make sure that they end in their quote and end in their square brace. All right, so we've populated the array. Next, we need to ask the user for the search value. So let's print a message. Find what color in the array, question mark, end quote, parentheses. And then target is equal to input. Now we're not going to do that float business, convert it to an integer float, because we're searching for strings, right? You can't convert the word red to a number. I'm going to test those 2 little chunks of code that I just added. It's still not going to do anything useful, but find what color in the array, blue. Data not found in array. That's appropriate because we still haven't written the while loop. All right, now for our while loop. While index is less than the length of the array, len, parentheses array. But let's add on that other clause so that it'll bail out early if it finds it. And found equals false. Keep going only while the found flag is set to false. Now we have an if statement. If, oh, for Pete's sake. If the array at our index is equal to our target, if array subscript index equals target, great, we found it. So quote, or excuse me, comment, we found it. And in that case, we set our flag to true, so found is equal to true. Remember that false and true always have to be capitalized in this language, so put a capital F in false everywhere and a capital T in true. Not true of other languages, Python quirk. And then found at is equal to index. That's where we found it at. Now I'm going to type one more line, and please unindent at one level, or else your code's not going to work. Make sure it's lined up with the if and not the code inside the if. Just go back one, and then we have to add one to the index. Index plus equals 1. Please no spaces between the plus and the equals. And then lastly, above this if found, let's just put a comment saying what we're doing. Check results. Find what color in the array. I'm testing it. I'll bring the code back. We found the data at index 1. I'm going to run it again. I'm going to look for something I know is not in it. Tangerine. Data not found in array. Okay, seems to be working. So if I remove this line, this blank line there, I take out this blank line above the while loop, I can get most of the code on the screen. All right, and then the last line of code is just else print data not found in array. All right, guys, I accidentally left the recording pause too long, so make sure that you read all the slides up to 31. So searching an array for a range match. Programmers may want to work with ranges of values. They may want 1 through 5 or 20 through 30 or whatever. Example, a mail order business. Read the customer order data. Determine the discount based on the quantity ordered. The first approach, an array with as many elements as each possible order quantity. Store the appropriate discount for each possible order. I'm not sure that I want to spend too much time on this. The drawbacks of the previous approach: requires a very large array. Stores the same value repeatedly. How do you know when you have enough elements? The customer could always do more. The better approach: create 2 parallel arrays, each with 4 elements. One array has the 4 discount rates. One array has the low end of each comparison quantity. And then use a loop to make the comparison. So what they're saying is, like, what if you have something that is in quantity ordered, and you wanted to, you'd actually input the quantity or whatever, you'd ask the database for it or whatever, and then you wanted to be able to check to see which discount they qualified for. So you can make an array, rates, and, at first there's no discount, but then pass a certain number, there's a 10% discount, and then pass another number, there's a 20% discount, and then pass another number, there's a 30% discount. And then the levels, the numbers of order at which you have to get those discounts. Okay, so to reach a discount of 10%, you have to order 100. To reach a discount of 20%, you have to order 1,000. And to reach a discount of 30%, you have to order 2,000. Whatever, right? And then you just write a loop that compared. For I in range, you know, the length of the rates. If the quantity is less than the nums, but greater than the nums. My brain kind of stopped on this. Then set our discount equal to the rate at subscript I. You'd want to start your discount at 0. I think I could optimize, and then you'd want to bail out of it with a break. I think it's unnecessary to have this first entry there. And I still think the logic is wrong. You have to go back and look at those slides. But the idea is that you have a list of discounts, you have a list of the quantity necessary, and then you use a loop. Did we have less than 100? Yeah. So we probably get no discount, or we only get a 10%. Do you have less than 1,000? No, so we only get the 20%. Do we have less than 2,000? No, we only get the 30%. That logic is not precisely right. It's pretty close. How about starting that one off at 0, so that if you buy less than 100, you get a 0. If you buy less than 1,000, you get a 10% discount. If you buy less than 20,000, you get a 20% discount. And if you otherwise, this is the part that I don't like, and I'd have to go back and look at their algorithm. But anyways, you get the idea. List of discounts, the minimum order required in order to achieve that discount. Let's go look see how they did it. So create 2 parallel arrays, each with 4 elements. One array has the discount rates, one array has the low end of each quantity range. So here we go. The discounts. 0, 10%, 15%, 20%. You get 0% if your order is within 0 to 8. You get 10% if it's between 9 and 12. You get 15% if it's between 30 and 25. And you get 20% if it's greater than that. We know that the concept is possible. I'm not going to ask you to write that code. So remaining within array bounds, it's always important to make sure that your index value does not exceed the length of the array, or else it could crash the program, or you'll get invalid results. You know, back in the old days, it could break the computer, crash the computer. Every array has a finite size, meaning it's fixed in length. The number of elements in the array corresponds with the number of bytes in the array in some way. So arrays are composed of elements of the same data type. Elements of the same data type occupy the same number of bytes, right? If an integer takes up 4 bytes, then each element in the array also takes up 4 bytes. So the number of bytes in the array is a multiple of the number of array elements, right? If we have 10 numbers and each one is 4 bytes long, then our entire array is 40 bytes long. And so we access data using a subscript containing a value that inside the computer is multiplied by the size of it, right? So if we have 10 integers, but you want to access integer 2, well, 0 is the first one, 1 is the second one, 2 is the third one. It knows to skip the first 4 bytes, and then the next 4 bytes, and then the next batch of them is correct. But what happens if you give it an index value that's past 10 or more? You know, if our array, I'm going to stop from going 10 to just 4 because it's easier to draw. You know, you have 4 elements here, 4 integers. Each one has 4 bytes in it. So that's element 1. That's element 2. That's element 3. 0, 1, 2, and 3. But if we were going to count them, that'd be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And so if we want to access element number 0, that's 0 times 4, because 4 is the size, is equal to 0. So element 0 starts at position 0. You want to start at element 1, 1 times 4, 4 bytes is equal to 4. So it would count from 0, 1, 2, 3, and then, okay, I'm going to start right here. That's a 4. If you want to get to element 3, 3 times 4, okay, I can do that. 3 times 4 is 12. I'm going to go to byte 12. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's index value 3. We found it. What if we have an invalid index? 4 times 4 is 16. We count them out, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, that one was 15. Who knows what is in that value past that point, right? It may merely return an invalid value, or the computer may detect that you're trying to read past the end of the array and then shut the program down. You probably have seen the Windows error message, your program has encountered an illegal instruction and will be quit. That's the kind of thing that can happen if you read invalid memory. So you have to remain within the array bounds or something bad will happen. Either invalid data will be returned or it will crash your program. So it's in bounds as if your subscript is within the acceptable range. This has an array length of 4, so we're allowed to go 0, 1, 2, and 3. It's out of bounds if it's not within the acceptable range for the array. Right? If it goes past that, we try to access element 4, 5, 6, 7, or whatever. Now Python makes it a little bit confusing by allowing -1. What does -1 mean? It means the last element of the array. So I can't say if you use negative numbers it'll crash the program. But past a certain point it would anyways, because Python's little quirk is letting you specify the last one is -1, -2, -3, -4. Well, you can't get any larger than that or smaller than that, or again, you're off in the great unknown, off the other side of the array. So when an invalid subscript is used, that's a logical error. Some languages stop execution and issue an error. Other languages go ahead and access that memory location, but it will contain invalid data. And so your program should prevent what are known as bounds errors, writing past the bounds. That's why we use that len parentheses array in order to make sure that we're not reading past the length of the array. In other languages, you would set some kind of constant, right? Len array is equal to 4, right? Or 10 or 100, and then your while loop would be based on that, you know, for x in range, you know, len array. However, you had to do it in that language, in the language of choice, to make sure that your loop would stop at the right point. This would count from 0 to 99. Why do I say that? Because since we didn't specify a first number, it defaults to being 0. I could have done that, but it's not necessary because it defaults to being 0. And I didn't specify my third value because if you leave that one off, it goes by ones. So yeah, I could fluff it up to the entire right syntax like that, but I'm going to leave that off. And we are about at the end of this. So to improve a program, you can add a test to ensure the entered subscript is valid. If you need to, you can do that. Like if you don't trust, like if you ask the user which number of the array to edit, you better check to make sure that they haven't entered an invalid value. So a for loop, a single statement, initializes a loop control variable, compares it to a limit, and alters it. It's especially convenient when you need to process every element in the array. And we've used for loops already. Here's how the book is describing them, but we're describing them in Python. For the department is equal to 0, do size -1, step 1. Looks exactly like our for loop, except we didn't have to put the -1 in our range statement. All right, we are done with the chapter, except for the summary. So why don't we make a Dropbox, and we will call ourselves done for today.